Welcome back to the course on green manufacturing systems. This is sustainability through green manufacturing systems and applied approach. This is an applied approach course where we will first understand the manufacturing systems, then we will see how manufacturing systems, how sustainability is related to manufacturing systems, and before that we need to understand what is sustainability, what is green manufacturing, and we will try to develop complete manufacturing systems that is sustainable, that is green, I would say. Green, or better I would say it is greener. Greener means it is performing better than its previous color. Okay. In this specific module, I am trying to cover life cycle assessment. Life cycle assessment, as I have taught, is a tool that helps to put your product in the specific benchmarking, in a specific color. So you can rate or you can label your product that at what stage it is with respect to the greenness. So in this lecture, I like to cover these contents. First is recirculation of resources. By recirculation of resources, I mean, which I covered in the previous lecture, we can reuse, we can recycle, and then we can dispose. So this reuse is a simple thing. Reduce we are not going to cover here. Reduce is just reducing your consumption. So that is not going to be covered in this recirculation process here. Reuse is reusing the component, reusing the product again and again after getting a little maintenance done. When we talk about recycle, in recycle there are certain intermediate processes involved. That implies to what extent is the product is recycled. We will cover this in the next slides here. Finally, product has to dispose. Next, I will try to cover the LCA procedure, the steps to conduct LCA. Conduct life cycle assessment. Then I will try to put some light on these concepts: embodied energy and energy ladder. What are these? Then when we have studied the LCA procedure, I will cover these using two examples, two case studies. One would be quantitative and one would be qualitative. So this will give you an overview that how LCA study is carried out. So we'll also try to cover some softwares, because LCA study, life cycle assessment study, is rarely done by manually, like just collecting the data and all those things. These days we have life cycle assessment softwares, and there's a long list of software which are available. There are open access softwares. There is EIOLCA, which is economic input output life cycle assessment, that is a database. Then we have certain softwares. We'll not cover the softwares in this course, but in the connected course, which will be a next course, we'll also cover the demonstration on these softwares. So next I have here is recirculation of resources. This is explained using this RICO comet circle. So this is a comet circle which is taken from RICO. RICO is a company that manufactures office stationery like printers, shredders, scanners, etc. So they came up with this comet circle. They call it a comet circle. See, what is comet? Comet is a heavenly body that revolves around the sun. So finally, what happens, the comet has a specific path. There is sun here, sun is here, the comet is revolving like that. It is coming close, getting away. So this orbit of the comet may be a few thousands of kilometers to a few millions of kilometers as well. So what happens, comets finally vanish. They are burnt into the sun. But before that, for a few hundred of years, for instance, this is the sun. For instance, if I say this is sun, and this is comet here, comet 1, comet 2. This is the orbit of comet. This is orbit of comet. I would put a comet. Orbit 1 of comet 1, orbit 2 of comet 2. So this is, if I put the comet is here, it would have a tail. The tail would be like, because it is burning, the heat is received from sun, and the tail of the comet is in the opposite side of this sun. So this is how comets work. So in this diagram, what Rico tried to present, they tried to present the comet circles which represent a sustainable society that recirculate resources. That is the kind of society that we pursue, that we need to pursue. The circles in the diagram represent the partners in that recycling based society. The upper root represents the arteries of the system and the inner root represents the veins of the system. So what is happening, see, if you can see, the user is here. This is this red color circle is the user. The user can, this is the first circle, the user can get his product maintained again and again and keep using it again and again. So this is maintenance. So this circle is maintenance. So I like you to know, the shorter the circle is, the shorter the orbit of the comet is, I will put it here, shorter the orbit, the sustainable is the product. I have put shorter is the orbit, sustainable is the approach. Like when you purchase a car, you do not, when the car is like after 5,000 kilometers, you have to get your car serviced. That is maintenance. That is known as preventive maintenance. We have three kinds of maintenance: preventive maintenance, corrective maintenance, breakdown maintenance. These are the three major kinds. However, there are certain other kinds as well. What is preventive maintenance? Like even before having any information regarding the failure of the product, like you get your car serviced at each 5,000 kilometers or if after each 6 months. So that is preventive maintenance. Like you want your automobile performance to be at par, and you keep on get it serviced again and again and keep using. So we have put, they have put here long use. So this is a long use and this is getting maintained again and again. However, sometimes the maintenance is corrective maintenance or predictive maintenance as well. So what is predictive and corrective maintenance? Predictive maintenance is when you get some signal, okay, like for instance, your brake stops working properly. You get and feel that the brake is not plunging properly, the car is not stopping at that rate as it should be. It means that you might have to get your brake shoe changed, or there might be some problem in the hydraulic system, brake hydraulic system. So that is the prediction. You have some indication. After that indication, you get that maintenance done. That is predictive maintenance. Next is corrective maintenance. Corrective maintenance is when small breakdown happens. For instance, your some part of your car breaks, your side mirror breaks, you get it maintained, you get it replaced. That is corrective maintenance. The small fault has occurred and you get that repaired. That is corrective. Last is breakdown maintenance. What is breakdown maintenance? That means your product has come to stand still. Your engine got jammed. Your I can even say, if your tires flat down, that is the breakdown. Your car cannot move forward. So you have to stop there. You have to get the stepney changed. That is kind of a breakdown maintenance. Or your engine gets jammed. You have to, your car completely stops over there. You have to get it repaired and then move forward. So there are 4 kinds of maintenance here. I can put it here. These are preventive, predictive, corrective, and breakdown. So we'll cover these in detail when we'll do the second part of this course, in which we'll do the design for maintenance, design for environment. So in those cases, we'll cover these in detail. So we'll see that how these 3 kinds of maintenance are helpful for having the sustainable or green product as well, when we'll see design for environment. So next circle here is the product goes to collection center, then product recovery center, then back to sales company, then to user again. This is the second circle, circle 1, and this is circle 2. So what happens when the user decide that he is not going to use the product? So I can put here there are two levels of use. One level can be we get the product repaired again and again, get the maintenance done and keep using it and again. You're using your car, for instance, for 5 years, for 10 years. After 10 years, you decide to not use this car and sell this car. This is also a second level of reuse. The second user who is willing to buy this second hand car and is willing to use this, he will use this again. So these are two reusing, like two levels of reusing. So next comes when the second owner, third owner and so on, when the last owner, he decides that he is not going to use the car and the car is finally to be disposed of. So what do? They dump the car. So do they completely dump the car into like landfills, or do they dump the car into sea? No. What happens? The car is sent to the collection center. And collection centers, what they do, they dismantle all the components. They separate the metallic and non-metallic parts. They then collect the parts which can be reused again. For instance, a few screws, few nuts, few components which can be used again, those are collected by this product recovery center. And they give it to a sales company and they can be again used as the spare parts. You can buy second hand spare parts. There is a big pawn market everywhere. Specifically in India, we have big pawn markets, big second hand spare parts market. If you need to buy some spare parts, for instance, one of my friends, he found that his brakes stopped working, his car. It was Maruti WagonR. So he thought to get that replaced. Actually, the mechanic said that that needs to be replaced completely. So the new component was costing rupees 6,000. But when he went to the spare parts market advised him that he can even go to the second hand market where the product that could be working equally good, that can be purchased, and he got it for 2,000 rupees. So these things are also happen. I am not saying that one should prioritize to use second hand parts, but this leads to sustainable society. So if everyone chooses the new spare parts only, so the second hand spare parts, what happened to them, they have to be disposed of, they have to be melted, they have to be converted into some other form again and again. So if we are reusing this again, so this is, I can even put this is a third level of reuse as well. Third level of reuse where the spare parts are taken out, they are dismantled and they are reused. So what they do, they dismantle different kinds of components of the car, the body, aluminum components, then steel components, nuts and bolts, rubber components, the glass, the side windows, glasses, all those all can be, before disposing of them finally, they can be reused if possible. So next cycle is the recycling center. So I would like to put here that this is reuse. I would like to correct here myself. So I like to correct myself that this is cycle 1 and 2. I'll put here cycle 1, cycle 2, cycle 3, cycle 4 here. I'm putting on the cycles, cycle 5, or I would say it is actually this is orbit, orbit 1, orbit 2, orbit 3, orbit 4, orbit 5, and these are miscellaneous, or these are actually, this is actually orbit 6, yes, orbit 6 and orbit 7. Okay, these are extensions of orbit 5 only. So this is 1, 2, 3, 4, 5, 6 and 7. So orbit 1 and orbit 2 are actually representing reuse. So next orbit is orbit 3. Orbit 3, which is in which the product goes to a recycling center. So what does recycling center do? Recycling center takes the product, it does sorting and disassembly. Actually, product recovery center can also do that. So they sorting and disassembly, then they sends to part recovery center, then it goes to the product manufacturer who can use the components again, then they send it to sales company, and then the product can again go to the user. So In this case also the product coming to the user, but the circle is larger. So as I said, shorter is the orbit, sustainable is the approach. So here the sustainability approach or sustainability extent is lesser in comparison to orbit 1 and 2. So next is orbit 4. So what is orbit 4? Once the different cycles of reuse have happened and there are no further possibility to reuse or recycle the product even again, so what happens when we need to send the product for disposal? Disposal is actually the final thing. Then we send it to a shredder company. What does shredder company do? They shred the metals. So the shredder company, they crush the products. This is Comet 4. They crush the products, shredder company. Then it is given to the material recover company. Material recover company, then it can, the user of recycling materials, they can reuse materials. Then we can even have closed loop materials recycling on open loop material recycling. Closed loop material recycling is when this material company, recovery company is sending the materials to the parts manufacturer. For instance, carburetor is to be manufactured and the aluminium that is used is to be again sent to the company who manufactures the carburetor. That is, this is actually the parts manufacturing company. So this is closed loop again. So what is closed loop and open loop here? By closed loop, it implies that this component, this specific product, for instance, I am talking about the automobile. The automobile component which is shredded, for instance, the carburetors, and for instance, any aluminium components in them, they are shredded, they go to the shredding company, then the material recover company, and they again go to the part manufacturer and come back to the user, not the same user, different user, however, it goes to the same kind of product again. That this car component is coming back to this kind of car again. So this is closed loop. Second can be open loop. What they do, material recovery company, they send the material to user recycling materials, they send it to a different company who can use this product for any purpose they like. Like aluminium has various applications. So steel, if it is recycled, it can have various applications. The thermoplastic materials have various different kinds of uses. It can be used there. So this is open loop. It might not come back to the same product, but it can be used anywhere they feel it is possible. So next orbit number 5 is when this shredder company, they crush the product and they send it to the smelting company, which is an oil recovery company. Actually, they generate raw materials like chemical recycling, metal recycling, all those things happen here. So they can again send it back to the materials manufacturer and it could go back again. So next is the final disposal. Before final disposal, we have sixth comet. Sixth comet or sixth orbit here is the thermal energy collection company, that is thermal energy collection company which recovers the energy, and after that the seventh part, the shredder dust, and also after this final energy recovery, it is sent for final disposal. What is final disposal? It is landfill. So the products like this, like products like automobile, which are small products, those are landfill. And the big products like maybe big houses, big ships, those are sent deep into, those are actually drowned deep into the sea. So that is also a big project to do that. And finally, this fossil and mineral resources, etc., goes to the material supplier by material manufacturing company. So this is the Comet Circle, which was brought by RICO, and it is said that to achieve a sustainable society that recirculates resources, it is necessary to recycle products through inner loops of the Comet Circle and promote recirculation that is highly economical and causes less environmental impact. So the partnerships are essential. So the thing is that how to conduct, how this is possible. For this, there are certain requirements. Number one is identify and reduce the impact at each stage. Okay. Number 2 is prefer inner loop, as I said again and again. So number 3 I could put here is promote partnership. So at each stage, the partnership is important and more economical rationing has to happen, rational rating has to happen. So what is happening here, you can see the product and money flows in opposite direction. The product comes to the user and the money goes to the sales company. The product comes to the sales company or the from the product manufacturer, and sale company gives to the product manufacturer. So it is important to establish a system that motivates the people, motivates all the stakeholders, the final users, which are the customers, and the other stakeholders in this whole diagram, to consider, to motivate them to use environment friendly products, to use the process that is environment friendly. This is important. For that, partnership has to happen. So we need to have environment friendly business activities, and we need to buy products with less environmental impact. So next is LCA procedure. LCA procedure, I can put that in steps here. So the first step here is goal and scope. Define the goal and scope for the life cycle assessment. That what is your goal and what is the scope of the study. The goal is fixing the aim, fixing the target, and scope is different thing. Goal, I can differentiate between two in a way that we need to put the boundary wall of our study. Like I said, there are 3 major stages: raw material stage, work in progress stage, and finished product stage. When we conduct this study, sometimes we go for all these stages, like taken into account. Sometimes we fix our scope, okay, we need to just see the life cycle assessment for the raw materials only, the raw materials which are conducted. Or we need to see the life cycle assessment, the scope is this one, work in progress or manufacturing facility only. So it all matters what kind of study we are doing. So this is scope, and even the scope can be defined in another way. Do we need to just compare? Do we need to just label our product, or do we need some improvement as well? One is just labeling, just assessing the present state. Second is we can even suggest the improvement. So if the improvement is suggested, then it is an extended life cycle assessment. So I can put it here. The goal is that may be comparison or improvement. Here in comparison, I can put it as labeling. Just we need to find our present state, present color, or do we need to do the improvement as well? That what is the goal? Scope here can be said like the boundary here. Boundary of study, that is these 3 stages: raw material. I can even put the 4 stages here: the raw material, then manufacturing, then assembly, and end use, and maybe disposal as well. Okay, what is our boundary of this study? I need to study before the product reaches the end user. So this would be my boundary, from the raw material to manufacturing and assembly. So this is the first step. We need to see what are the inputs here to find goal and scope. and what are the outputs here? Outputs, inputs. Second step is we conduct inventory analysis. By inventory analysis, I would mean the inputs and outputs which I have put in here, the inputs and outputs. Both inventories, what are the inventories here? Inputs, outputs, then also we can have work in progress inventory from here. This is raw material inventory, this is work in progress inventory, and this is maybe finished goods which are manufactured before reaching end user. So these kinds of inventory. For inventory analysis, one need to do this inventory analysis is not just the material inventory. In material inventory, what we do like economic order quantity, what is the quantity that we need to put to minimize the cost. This is the inventory analysis of the energy that is embodied, that is consumed during processing and all these things. So it is actually the process energy. Then in case of raw materials, we can have feedstock energy. And the outputs, because finished goods are here, because we are doing inventory analysis and we are more concerned about the impact, environmental impact, we also need to see the waste, pollutants, etc. So what essentially we are doing here is we are actually collecting all relevant inputs and outputs. That is actually, this is data collection. So this is inventory analysis in which we are collecting data. Next step is the impact analysis. In impact analysis, what we do, and in inventory analysis also, we need to see the life cycle impact analysis. This is LCIA. Most of the times you will find this term LCIA, life cycle impact analysis, which is the analysis of the existing practices and the new practices. Actually, this is existing only, existing practices. What is the impact in terms of energy consumption, that is embodied energy is also involved in this. I'll define embodied energy or explain embodied energy just in next slide. And by energy consumption, I would put here better the energy from all the resources. That is resources consumption. Resources here energy. Energy may be embodied energy, embodied energy may be direct, maybe indirect, maybe recurring. If embodied energy is direct, we'll see that what kind of resources are here. We'll just see that in next slide. And next is impact analysis. This is impact for energy and the environmental impact, the pollution or waste. So after impact analysis is conducted, we'll just see these in a case study. So next we evaluate. Evaluate the impact categories. What is the, in terms of pollution, what is water pollution, what are water intensive resources here, and what is solid pollution, what is pollution to air, what is the cost that is associated, might be one of the things associated to recycle if the waste is there, then what is the energy consumed. So we evaluate the categories of impact, or better to put it, impact categories. Impact categories. Then if our goal is the second point here, the goal can be number 1, comparison, goal can be number 2, improvement. If the goal is the second point here, improvement, we'll make suggestions for improvement. And in an extended life cycle assessment, besides giving suggestions for improvement, they can also implement and monitor. I can put that as one point here. Implement and monitor. Monitor or maintain. For maintain, we need to have the feedback, that because we were looking into existing practices here in the third step, the existing practices were sought, and we'll have feedback for new practices. Feedback for new practices, and based on the feedback, we'll try to control. So this is a general procedure for life cycle analysis. So before moving forward to the case studies, I'd like to put some light on these two concepts, embodied energy and energy ladder. What is energy ladder? Energy ladder is a concept in which the households, they decide to use the fuels which are of high level of energy. For instance, one can decide the solar energy, we can put the clothes to dry in sun. But if he uses the washing machine that is having heater and dryer in it and spinner in it, that is consuming electric energy, that is the higher level of energy. So this energy ladder, what does it do? It describes the way in which households will move to the more sophisticated fuels as their economic status or income improves. So one who can afford the higher level of energy, they use that. Like though households do move away from wood to kerosene and electricity as their economic status improve. So energy ladder can be put in this way. So this is a ladder that one needs to climb, and it has certain steps in it. So it is the socio-economic status here So what happens? The lowest form of energy is the firewood, agriculture waste, the animal dung that is used to cook food in rural areas in India, and I can put it here. Firewood, agriculture waste, then animal waste. So next kind of the fuel here could be the transition fuels. The transition fuels are in between the high level and low level. The high level of fuels are like we use LPG in our homes to cook food. We use electricity. We use biofuels. And in between we can have charcoal, which are transition fuels, then kerosene, then coal, and wood also. Actually, wood should be here. I'll put better. Charcoal here. Wood should be, because wood produce more pollution. That I'll just like to say here, that the pollution level here, it is more direct pollution on this side. You can put coal here. So even these days there is a much higher level of energy. So we have solar energy, and we have the renewable forms of energy, hydrogen energy, wind energy, these things. So it is more direct pollution on this side. That means we have cleaner energy. So I have put it here. I like to let you know that the power, there are certain kinds of power plants: thermal power plant, nuclear power plant, the hydel power plants. The energy that is produced from thermal power plants, because the coal is used here, the quality of energy is low with respect to the energy ladder, because coal is in the lower side of in the energy ladder. If it is the hydel power plant, only the water flow is used to run the turbines, the pressure of water, the quality of energy is better. It is the better quality energy. And if it is nuclear power plant, the energy produced is much better. I'll just come with a chart for example in embodied energy in the next slide, where we will see that different countries are using that the developed countries are using the better kind of fuel to produce energy, to produce power. And the best form here I can say is solar energy. We have solar power plants, we have wind turbines, wind power plants. Like the energy that is produced is just due to the wind currents, and geothermal energy is also there. Those are also used. We'll discuss that in the further sessions in this course. Then solar energy, solar power plants are there. So what happens? This is the energy versus greenhouse gases illustration that was developed by Mackay in 2009. So what is this illustration trying to tell us? It is telling the carbon intensity of electricity production, that is the grams of carbon dioxide that is produced per kilowatt of electricity, or the units conversion, it is 0.001 megaton per megawatt hour. So it is 83 grams of carbon dioxide, that is carbon intensity here, to produce 1 kilowatt of energy. 1 kilowatt hour of energy. It is 83 grams to produce 1 kilowatt of energy. See, France, Sweden, they mostly have nuclear power plants. So these France and Sweden and countries which are use nuclear fuels, which mostly have nuclear power plants. The Canada, which is at number 3, that is having the wind power plants at like big number. So the carbon intensity that is produced is much lesser in comparison to the countries which are in the bottom rows here. So in the bottom row we can say we have USA. USA is 7.4 times with respect to France. We have Japan, which is 5.8 times with respect to France. So it is also put China and India here. In China and India, the most of the plants are, the most of the energy production plants are thermal based. They use coal. That is why, see, India is at the bottommost position. It is 944. For 944, if it is divided by 83, it might be 12 times. So the pollution that is produced by India is about 12 times of in comparison to France to generate electricity. So they have just put an example here. The new cars embodied energy is approximately this much. So if the new car's embodied energy is this much, for in France, for manufacture of this car, the total energy, the same car, same process steps, what would happen? The total energy would be the energy used to manufacture one car, for one car into the carbon intensity, that is 6.3 megaton of carbon intensity of this much of carbon dioxide is produced to manufacture one car in France, and in Japan it is 36, in US it is 46, in India it is 71, the large number. So this is one illustration I am trying to present here, that energy ladder, that is a term that is used for the households only, but for the but on the very large scale also, for the countries which are using the policies which are having these kinds of plants, in those cases although these things matters. So I'll come up with the case studies for quantitative data and qualitative data in the next part of this lecture. So thank you.